2:45 in the morning. Andersen Air Force Base, Guam. The radar screens at the Combined Air Operations Center were suddenly saturated with thousands of small, low-altitude contacts that had bypassed every early warning buoy in the Philippine Sea. No one knew how a force this size had reached the heart of the second island chain undetected, or if the defenses could wake up in time to save the primary hub of the United States Indo-Pacific Command. The tropical air was heavy with humidity and the faint, sweet smell of jungle vegetation. Above the concrete runways, the sky was a deep, starless void that offered no hint of the kinetic storm about to break. The first wave did not arrive with the roar of jet engines. Instead, there was a high-pitched, collective whine like a billion angry insects descending from the north. These were not the massive, long-range drones of the previous decade. These were small, carbon fiber autonomous strike munitions launched in secret from modified commercial containers or submerged platforms. They moved in a coordinated swarm guided by decentralized artificial intelligence that required no human pilot and no continuous satellite link. At exactly 2:48 in the morning, the first munitions crossed the perimeter fence. The primary targets were not the hardened bunkers or the command centers, but the exposed, high-value assets parked on the northern ramps. These aircraft, the crown jewels of American air power, sat in neat, disciplined rows, fueled and ready for the morning's scheduled sorties. 6 F-22 Raptor stealth fighters, each worth nearly $200 million, were the first to be hit. The drones did not need heavy warheads to be effective. They used shaped charges no larger than a handheld camera designed to punch through the delicate, radar-absorbent skin of the Raptors and ignite the volatile jet fuel within. The first explosion was a sharp, localized crack that sounded like a heavy hammer hitting an anvil. Within 2 seconds, the entire flight line was a corridor of orange fire. The sophisticated stealth coatings, designed to hide the aircraft from the most advanced radar systems in the world, melted away in seconds under the intense heat. To the south, on the heavy bomber aprons, the destruction was even more catastrophic. 5 B-52 Stratofortress bombers, the massive workhorses of the strategic deterrent, were engulfed as drones dived into their exposed engine nacelles. One bomber, fully loaded with conventional cruise missiles for a long-range exercise, suffered a secondary detonation. The blast wave shattered the windows of the air traffic control tower over 2 miles away and sent a column of black smoke 300 meters into the night sky. The base alarms finally began to scream, but for 30 aircraft, the warning came too late. On the maintenance ramps, 4 C-17 Globemaster transport planes and 3 KC-135 Stratotankers were ripped open by synchronized strikes. The tankers, carrying tens of thousands of gallons of high-octane fuel, turned into massive, stationary fireballs that lit up the entire northern end of the island. Security forces in their armored vehicles raced toward the flight line, their heavy machine guns opening fire into the dark sky, but they were shooting at shadows. The drones were too small, too fast, and too numerous for traditional point defenses to track manually. Spent brass casings clattered onto the asphalt as the defenders realized they were witnessing a new era of warfare where the most expensive weapons in the world could be neutralized by a swarm of disposable machines. By 3 in the morning, the first wave of the attack had concluded. 30 United States aircraft lay in various states of ruin across the airbase. The air smelled of burnt rubber, chemical foam, and the heavy, oily stench of unrefined kerosene. Fires crawled across the concrete, fed by the rivers of fuel leaking from ruptured wing tanks. Personnel scrambled out of their barracks, many still in their undershirts, staring in shock at the devastation. The invincible fortress of Guam, the unsinkable aircraft carrier of the Pacific, had been pierced. Commanding officers at Indo-Pacific Command Headquarters were already on secure lines to the Pentagon. The initial report was grim. In 15 minutes, more American airframes had been lost on the ground than in any single engagement since the Vietnam War. But the radar operators knew the nightmare was not over. Far out over the Pacific, Another massive cloud of contacts was forming on the edge of the sensor range. The first wave had been the decapitation strike. The second wave was intended to be the funeral. 3:05 in the morning. Andersen Air Force Base was no longer a structured military installation. It was a geography of fire and localized chaos. The initial shock of the 30 lost aircraft was rapidly being overtaken by a much larger threat to the entire Western Pacific capability of the United States. The primary fuel farm, located on the northeastern edge of the airfield, had become the focal point of the second swarm wave. This facility held over 2 million gallons of JP-8 jet fuel, the lifeblood of every fighter and bomber remaining on the island. As the first sirens of the 36th Civil Engineer Squadron began to wail, a fresh cluster of 85 strike drones descended from the low cloud ceiling. They did not target the hardened storage tanks initially, but rather the exposed pumping stations and the manifold headers. The sound was a series of rapid, metallic pops, followed by the deep, guttural roar of high-pressure fuel igniting. Within seconds, a river of burning liquid began to flow across the service roads, cutting off the primary access for the base fire department. The air was thick with the suffocating smell of chemical fire suppressant and the oily, black smoke of burning kerosene. The temperature near the fuel farm rose to over 800 degrees in less than 3 minutes, melting the asphalt of the adjacent taxiways. 4 P-19R aircraft rescue and firefighting vehicles, each carrying 1,000 gallons of water and 130 gallons of foam concentrate, moved into position. The crews, wearing silver proximity suits that reflected the orange glare of the inferno, operated with the grim efficiency of men who knew that if the main tanks went, the base would be lost for months. In the maintenance area, the situation was equally dire. 3 massive hangars, designated as buildings 1000, 1001, and 1002, were under direct assault. These structures were not hardened against kinetic impact. A group of 40 drones, operating with swarm intelligence, identified the structural weak points of the roof trusses. They struck in rapid succession, one after another, until the weight of the debris and the heat of the internal fires caused the massive steel beams to buckle. Inside Hangar 1000, maintenance crews from the 734th Air Mobility Squadron were attempting to tow a damaged C-17 transport plane to safety. The sound of the roof collapsing was like a freight train falling from the sky. The massive steel doors, weighing several tons each, were blown outward by the internal pressure of the explosion. 12 personnel were caught in the collapse, their radios going silent as the structure folded inward. The smell of hot metal and pulverized concrete filled the air, a dry, choking dust that coated the lungs of every survivor in the vicinity. Despite the devastation, the professional discipline of the United States Air Force began to manifest. In the dark, under the constant threat of more falling munitions, senior non-commissioned officers began to organize ad hoc defense perimeters. They were not just fighting a fire, they were fighting for the survival of the mission. Every gallon of fuel lost and every hangar destroyed meant a longer delay in the inevitable American counterattack. The base commander, operating from the hardened alternate command post, issued the order for all non-essential personnel to take cover in the subterranean bunkers. The primary goal was now damage limitation. The air traffic control tower had been abandoned due to the smoke, and the base was essentially blind. On the fringes of the airfield, the security forces' MH-60 Sierra helicopters were attempting to lift off, their rotors whipping the smoke into cyclonic towers of black soot. At 3:15 in the morning, the second wave finally began to dissipate, but the damage to the infrastructure was nearly total. The fuel farm was a landscape of twisted pipes and towering flames that would take days to extinguish. The 3 hangars were smoldering ruins of blackened steel. The mission capability of Andersen Air Force Base had dropped to less than 10% in under 40 minutes. The cost was being measured not just in billions of dollars of hardware, but in the strategic paralysis of the entire theater. Yet, amidst the ruin, the first signs of a systematic American response were appearing. The power of a superpower is not just in its initial strength, but in its ability to absorb a blow and reorganize while still under fire. The scramble was no longer about saving planes. It was about reclaiming the base from the fire. The first wave had been a shock, the second a tragedy. But as the third wave appeared on the long-range monitors, the defenders of Guam were finally finding their rhythm. 3:20 in the morning. The Joint Intelligence Center Pacific and the hardened command bunker beneath the jungle floor of Guam. Intelligence analysts were already dissecting the high-resolution data from the first 40 minutes of the engagement, trying to understand how a force of nearly 4,000 low-cost munitions had achieved total surprise against the most advanced sensor network in the world. The technology was identified as a decentralized mesh network, a logic system where no single drone acted as a leader. If 10 units were shot down, the remaining 1,000 instantly recalculated their flight paths to cover the lost sectors. The air in the bunker was cool and recycled, smelling faintly of ozone and floor wax, a sharp contrast to the burning jet fuel and scorched earth 10 meters above. The saturation tactic was a calculated exploitation of the physics of radar. While the AN/SPY-6 radar systems on the destroyers offshore and the land-based sensors were capable of tracking objects at incredible speeds, they were being overwhelmed by the sheer volume of low radar cross-section targets. The screen of a typical air defense operator did not show 30 distinct threats. It showed a solid wall of electronic noise. The drones were flying at altitudes of less than 30 meters, masked by the jagged terrain of the northern Guam coast and the high salt content of the tropical air, which further degraded the clarity of the return signals. The weapon system itself was a variant of the Chinese-manufactured Blowfish series, but heavily modified for long-range autonomous operations. These units were roughly the size of a large suitcase, powered by high-density electric motors that left almost no thermal signature for heat-seeking missiles to lock onto. They had been launched from a fleet of modified merchant vessels and submersible barges positioned 300 miles to the northwest, outside the standard identification zones. This was the realization of the 1,000-ship strategy, where civilian infrastructure was used to mask a massive military strike. In the electronic warfare suites, the battle was being fought in the invisible spectrum. The drones were not just physical threats. They were emitting localized jamming signals that flickered across the United States communications bands. Every time a Patriot missile battery attempted to achieve a hard lock, the drone swarm would shift frequencies in a synchronized dance, causing the interceptor's computer to reset its tracking logic. It was a digital fever, an infection of the network that made the defenders' most sophisticated weapons second-guess their own sensors. The drones operated on a sacrificial logic. In the first wave, several hundred units had been programmed to fly directly into the known positions of the base's early warning radars. They didn't need to destroy the entire installation. They only needed to shatter the delicate glass radomes and sever the fiber optic cables. With the primary sensors blinded, the second wave had been able to loiter over the flight line, selecting the most expensive aircraft with a cold, mathematical precision. The analysts noted with grim realization that the drones had prioritized the F-22 Raptors and the B-52 bombers over the older aircraft, proving the swarm's onboard artificial intelligence could distinguish between airframe types in real time. As the third wave began to coalesce on the horizon, the tactical picture became clear. This was not a random attack, but a systematic dismantling of the American ability to project power from Guam. The electronic warfare environment was now so dense that even the satellite uplinks were beginning to stutter, leaving the base commander to rely on hardwired landlines and runners to communicate with the remaining defensive batteries. The humidity of the night seemed to press down on the radar operators, their faces pale in the blue light of their consoles as they watched the next wave of 400 dots begin their final approach. The United States military was facing a paradox of modern warfare. They possessed missiles that cost $2 million each, designed to kill high-performance fighter jets, but they were being asked to use them against drones that cost less than $10,000. The math of the engagement was heavily skewed in the favor of the attacker. For every interceptor fired, the United States was losing the economic war, even if the missile hit its target. The saturation was not just physical and electronic, it was an assault on the logistics of the defense itself. Behind the scenes, the Indo-Pacific Command was already authorized to release the first countermeasures of the Steel Umbrella Protocol. They were no longer trying to identify individual targets. They were preparing to turn the sky over Andersen Air Force Base into a wall of kinetic energy. The command was simple. Anything in the air that did not have a friendly transponder code was to be destroyed by any means available. The era of precision engagement was over for the night. The era of mass-on-mass attrition had begun. 3:25 in the morning. The northern edge of taxiway Juliet. 2 F-22 Raptors, tail numbers, Air Force 051 and Air Force 054, sat with their twin engines already screaming in the humid dark. These were the only two fifth-generation fighters on the northern ramp that had escaped the initial wave of the drone strike. Major Sarah Jenkins, call sign Claw, watched the digital displays in her glass cockpit flicker with the reflected orange glow of the burning fuel farm half a mile to her east. The air outside her canopy was a thick, suffocating soup of tropical moisture, pulverized concrete dust, and the acrid chemical stench of burning radar-absorbent skin from the destroyed aircraft nearby. This was not a standard combat sortie. It was a desperate gamble to get the base's most capable air-to-air assets into Kepler. The sky before the third wave of the swarm could pin them to the ground. The primary runways were already cratered and littered with the smoking remains of the B-52 bombers, leaving only a 1,600-foot stretch of the secondary taxiway as a viable launch point for an F-22 Raptor fully loaded with 8 internal missiles. This was a distance that defied every safety manual in the United States Air Force. Below the wings, a skeleton crew of ground technicians from the 27th Fighter Squadron worked in a frantic blur. They were wearing full chemical biological protective gear, their movements heavy and labored in the heat as they hand-cleared a narrow path through the debris of the first attack. Every few seconds, the ground shook as a stray munition detonated somewhere on the base, but no one stopped. The crew chief gave a sharp, horizontal slash with his glowing orange light sticks, the signal that the path was as clear as it would ever be. Major Jenkins keyed her radio, her voice calm despite the master caution lights flashing on her primary flight display. She told her wingman, Captain Marcus Thorne, to ignore the foreign object debris alarms and to initiate a maximum performance climb the moment they reached rotation speed. Thorne, positioned 50 feet behind her, acknowledged with a double click of his mic. The two pilots knew that if a single piece of shredded tire or a stray bolt was sucked into their Pratt & Whitney F-119 engines, the aircraft would disintegrate before it ever left the concrete. The roar of the engines transitioned from a low rumble to a chest-compressing thunder as Jenkins pushed the throttles forward into full afterburner. Two massive plumes of blue-white flame ripped through the darkness, illuminating the jagged edges of the taxiway and the wreckage of the nearby hangars. The Raptor lurched forward, its high-tech tires screaming against the uneven surface. At 80 knots, the jet hit a patch of standing water and hydroplaned for a terrifying half-second. But Jenkins corrected with a sharp jab of the rudder. Her eyes locked on the end of the short, concrete strip. At 140 knots, she pulled back hard on the side stick controller. The thrust vectoring nozzles at the rear of the aircraft pivoted, redirecting 20 tons of force and forcing the nose into the air. The Raptor didn't so much fly as it was blasted into the sky, clearing the perimeter fence by less than 10 feet. Behind her, Captain Thorne followed, his afterburners scorching the asphalt, as he punched through the smoke of a nearby burning transporter plane. As they retracted their landing gear, the two pilots were immediately slammed by the reality of the electronic warfare environment. Their tactical data links, which normally provided a godlike view of the battlefield, were a chaotic mess of ghost contacts and false radar returns. The drone swarm was so dense that the aircraft's sensors were struggling to distinguish between the ocean spray and the thousands of carbon fiber targets closing in on the island. Jenkins banked her Raptor into a steep, 70-degree turn, her G-suit inflating around her legs to keep the blood in her brain as she pulled 6 times the force of gravity. Above the den clouds, the air was cold and clear. But below her, Guam looked like a glowing ember in the Black Pacific. She could see the streaks of tracer fire from the base defenses reaching up like fingers of light, trying to catch the swarms that were now less than 5 miles from the airfield perimeter. The two Raptors were now the only high-altitude eyes for the base commander. Jenkins switched her radar to a narrow-aperture synthetic mode, trying to burn through the jamming signals. She found the core of the third wave, a dense, undulating mass of 300 drones flying in a tight V formation at an altitude of 500 feet. They were moving at 200 knots, heading straight for the primary command and control center. Major Jenkins armed her AIM-9X Sidewinder missiles and signaled Thorne to spread out for a pincer maneuver. They were outnumbered 100 to 1, and they were flying into a digital storm that was designed to blind them. But as she leveled her wings and accelerated toward the incoming swarm, the fear was replaced by the cold, calculated precision of a trained hunter. The Raptors were in the air, the engines were holding, and the United States Air Force was finally ready to strike back. 3:30 in the morning. The limestone ridges of Mount Santa Rosa and the hidden clearings of Northwest Field. The soldiers of the 94th Army Air and Missile Defense Command were no longer watching a training simulation. They were operating the most complex, integrated air defense network ever deployed on American soil. Across the northern half of Guam, the silent desert tan canisters of the Lestis Patriot MIM 104 missile batteries and the towering THAAD launchers were pivoting toward the Philippine Sea. The humid night air vibrated with the low-frequency hum of massive mobile generators, a sound that competed with the distant, rhythmic thud of secondary explosions still echoing from Andersen Air Force Base. The electronic heart of the defense was the ANTPY-2 radar, a phased array system capable of detecting a golf ball at a range of hundreds of miles. However, the radar operators inside, the darkened engagement control stations, were facing a tactical nightmare. The incoming third wave was not a ballistic missile or a high-speed fighter jet targets. The system was designed to kill with single-digit precision. Instead, they were hunting a digital ghost, a cloud of 400 small, low-altitude strike munitions that were using the jagged coastal cliffs to mask their approach. Inside the control van of Battery Bravo, the air smelled of recycled oxygen and the sharp, metallic tang of overheated electronics. Sergeant First Class Elias Vance stared at a screen that was a chaotic tapestry of flickering green icons. The swarm was closing at 3 miles per minute. Under the steel umbrella protocol, the engagement logic had been shifted from quality to quantity. The system was no longer waiting for a perfect identification of each target. It was now programmed to create a wall of kinetic interceptors that would saturate the airspace before the drones could reach the primary command bunkers. At 3:32 in the morning, the first Patriot interceptor left its canister. The launch was not a gradual climb, but a violent, earth-shaking eruption of white light that bleached the surrounding jungle for 3 seconds. The missile accelerated to Mach 4 in an instant, its solid fuel rocket motor screaming as it tore through the humid atmosphere. 2 seconds later, another launcher cycled, then another, until 12 interceptors were in the air, their white exhaust trails crisscrossing the black sky like the ribs of a glowing cage. These were the latest variant of the Patriot missile, designed specifically for high-density engagements. As the interceptors reached the edge of the drone cloud, they did not impact a single target. Instead, they utilized a proximity-fused fragmentation warhead. At an altitude of 400 feet, the first missile detonated, releasing a cloud of several thousand tungsten pellets at 3 times the speed of sound. The sky was momentarily filled with a jagged flash. The result was immediate and physical. The lead elements of the drone swarm were not just shot down, they were shredded. Carbon fiber wings were sheared off, and high-density battery cells were punctured, leading to a cascade of mid-air electrical fires. To the observers on the ground, it looked like a meteor shower in reverse, with hundreds of burning streaks falling toward the dark Pacific. But for every 10 drones destroyed by the fragmentation clouds, 20 more adjusted their flight paths, diving even lower to skim the wave. Tops where the radar clutter was most intense. The THAAD batteries, designed for high-altitude intercepts, were now being slaved to the shorter-range Patriot sensors to provide a secondary layer of tracking data. The coordination was a masterpiece of United States Army networking, with data flowing through hardened fiber optic lines at light speed. Despite the heavy jamming from the Chinese offshore platforms, the American fire control computers were beginning to win the battle of electronic attrition. They were isolating the unique wave signatures of the drone motors and filtering out the noise of the ocean spray. On the perimeter of the airbase, the short-range defense systems, the MHEL laser platforms, and the mobile gun systems were also coming online. The soldiers manning these batteries could see the fires of the fuel farm in their rearview mirrors, a constant reminder of the cost of failure. The air was thick with the smell of ozone and the heavy scent of damp. Earth kicked up by the heavy vehicles. They were the final line of the umbrella, waiting for the drones that slipped through the Penchas long-range missile screen. By 3:38 in the morning, 64 interceptors had been fired. The cost of the munitions spent in the last 6 minutes exceeded $180 million. Yet the swarm was still coming. The steel umbrella was holding, but its ribs were being tested to the breaking point. The radar operators knew that a fourth wave was already forming behind the third, and the supply of interceptor missiles on the island was finite. This was a battle of industrial capacity as much as tactical skill, and for the first time in the engagement, the American defenders were beginning to wonder if the umbrella would break before the storm ended. 3:40 in the morning, the Philippine Sea and the northern cliffs of Andersen Air Force Base. The destroyers, USS Higgins and USS Howard, were positioned as the final kinetic barrier between the open ocean and the primary runways. The air was a heavy, salt-laden mist that clung to the steel of the decks, smelling of the deep Pacific and the faint, drifting smoke from the fires on land. The Aegis combat system was operating in a fully automatic, high-intensity mode, slaving every gun on the ships to a single, unified fire control network. The tactical objective was absolute: create a wall of fire at coordinates 13 degrees, 35 minutes north, 144 degrees 50 minutes east, through which no drone could pass. The swarm had reached the final 5 miles of its approach, a dense carpet of 200 strike munitions skimming just 10 feet above the wave tops. At this altitude, they were below the minimum engagement height for the larger interceptor missiles, forcing the defense to rely on the raw, mechanical power of rapid-fire cannons. On the deck of the USS Higgins, the sailors stood in the red light silence of the interior compartments, feeling the ship heel over as the captain maneuvered to give the starboard guns a clear field of fire. The operator on the USS Higgins slammed the consent switch to manual override as the swarm breached the inner 500-meter bubble. The 20mm Vulcan cannon of the close-in weapon system shrieked into life, a mechanical scream that tore through the salt air at 4,500 rounds per minute. A solid stream of white-hot tracer fire reached out from the deck, the smell of burnt cordite and hot grease instantly filling the gun tub. The first wave of 6 drones was punched into spinning fragments of carbon fiber and lithium-ion batteries before they could even begin their terminal dives. A massive orange fireball erupted just 30 meters from the hull, the heat blast scorching the gray paint and sending a physical shockwave that rattled the teeth of every sailor on the bridge. The remaining drones in the cluster swerved violently, their internal logic processors struggling to calculate a path through the wall of lead. One drone clipped the ship's radar mast, spinning wildly before slamming into the sea and erupting in a brilliant white flash that bleached the darkness. Black smoke and the oily sheen of pulverized electronics coated the surface of the water as the mechanical buzzing of the swarm was momentarily silenced by the roar of the ship's defensive fire. On shore, the defense was mirrored by the land-based Centurion CRAM systems positioned at the end of the runways. These were the ground-based equivalents of the shipborne cannons, mounted on heavy trailers. As the drones that had bypassed the ships reached the airfield perimeter, the 4 Centurion units opened fire in a synchronized crossfire. The sky over the northern end of Guam was suddenly illuminated by thousands of high-explosive 20mm rounds, each one programmed to detonate in a self-destruct flash if it missed its target. The sound was a continuous, vibrating thud that could be felt in the chest of every airman huddled in the concrete bunkers. The drones were being intercepted at a rate of 1 every 2 seconds. The air was filled with a rain of hot metal spent brass casings and shredded drone components falling onto the taxiways like lethal hail. The smell of ozone from the nearby laser defense prototypes mingled with the sulfurous bite of the cannon exhaust. One drone, its wing sheared off by a lucky hit, tumbled into an empty maintenance shed, the resulting explosion throwing a sheet of corrugated metal 50 feet into the air. By 3:50 in the morning, the wall of fire had successfully neutralized 188 of the 200 targets in the third wave. The remaining 12 munitions had been forced to break their formation, scattered by the intense electronic jamming and the physical barrier of the tracers. They were hunted down individually by the base security forces' MH-60 Sierra helicopters, which used their door-mounted machine guns to pick off the stragglers over the jungle canopy. The immediate threat of the third wave had been broken, but the cost to the defense was significant. The USS Higgins had expended over 10,000 rounds of 20mm ammunition. In under 4 minutes, nearly half of its total magazine capacity for the close-in weapon systems. On land, the Centurion barrels were glowing a dull cherry red from the heat of the continuous fire, requiring immediate cooling and maintenance before they could engage again. The sea around the northern tip of the island was no longer black. It was littered with thousands of floating white fragments of drone hulls, bobbing in the swells like the bones of a shattered army. The smell of the ocean was gone, replaced entirely by the chemical stink of a modern high-intensity engagement. The professional discipline of the United States Navy and Air Force had held the line, but as the first hint of gray light beginning to touch the eastern horizon, the radar operator saw a fourth cloud of dots forming. The battle for Guam was moving into its most desperate phase, the struggle for resupply under fire. 3:55 in the morning. The primary flight line at Andersen Air Force Base. The 554th Rapid Engineer, Deployable Heavy Operational Repair Squadron, known as Red Horse, was already moving onto the concrete of runway 0-6 right. This unit was the backbone of the base's ability to recover from a kinetic strike, and their mission was clear: restore at least 7,000 feet of takeoff surface before the fourth wave of the swarm reached the inner defense perimeter. The air was a thick, gray haze of pulverized limestone and the lingering, sulfurous odor of intercepted munitions. The giant mobile floodlights of the engineering teams cut through the gloom, casting long, frantic shadows across the cratered asphalt. The primary runway had been struck by 4 independent kinetic munitions during the second wave, leaving 3 craters, each approximately 5 meters in diameter and 3 meters deep. Under the Rapid Runway Repair Protocol, the engineers did not have the luxury of traditional construction. They utilized a high-tech triage system for the concrete. 2 massive front-end loaders, their engines roaring in the humid night, began by clearing the jagged debris from the impact sites. The sound of steel scraping against broken pavement was a constant, jarring screech that echoed off the nearby revetments. Following the loaders, a team of 30 airmen in charcoal gray tactical gear began the crushed stone phase. They dumped 12 tons of graded aggregate into the largest crater, using vibratory compactors to settle the base in less than 6 minutes. The technical precision was absolute. The surface had to be level within a tolerance of less than 2 centimeters to prevent a multi-million-dollar fighter jet from collapsing its landing gear during a high-speed takeoff. The heat from the nearby burning fuel farm made the air shimmer, making the task of laser leveling the repair site a test of both technology and human endurance. Once the stone base was set, the team deployed the folded fiberglass mat system. This was a series of interlocking, heavy-duty panels that were dragged over the repaired crater and anchored into the surviving concrete with high-strength bolts. The sound of the pneumatic drills was a rhythmic, industrial staccato that signaled the base's refusal to stay down. The smell of hot fiberglass and the chemical bite of the rapid-set resin used to seal the edges filled the lungs of the engineers, who worked without pause even as the distant thud of the offshore naval guns reminded them that the sky was still contested. Simultaneously, 2 miles to the south, the 36th Medical Group was establishing a Level 2 triage center near the collapsed remains of Hangar 1000. The site was a landscape of twisted steel and shattered glass, illuminated by the rhythmic blue and red flashes of emergency vehicles. The medical personnel, wearing armored vests over their flight suits, moved with a grim, practiced speed. They were treating the 12 personnel who had been caught in the structural failure during the second wave. The triage area smelled of high-grade antiseptic, damp earth, and the metallic tang of blood. The medical officers used handheld ultrasound scanners to identify internal injuries in the flickering light of portable LED lanterns. Of the 12 extracted from the rubble, 4 were classified as immediate and required urgent stabilization for crush syndrome and severe lacerations. The sounds of the medical bay were a surreal mix of hushed, professional commands and the constant, high-pitched whine of the portable oxygen concentrators. The logistics of survival extended beyond the runway and the clinic. Under the cover of the steel umbrella, 5 heavy tactical trucks from the 73rd Logistics Readiness Squadron were attempting to move a fresh supply of 20mm ammunition to the depleted CRAM batteries. The drivers navigated by infrared vision, their headlights off to avoid becoming targets for any loitering drones. They moved at 20 kilometers per hour through the debris-strewn service roads, the heavy crates of ammunition rattling in the back of the armored transports. By 4:15 in the morning, the engineers of the 554th had successfully patched 2 of the 3 primary craters. The runway was beginning to look like a functional airfield again, though it was now a patchwork of gray concrete and dark fiberglass mats. The 36th Medical Group had successfully stabilized all 12 casualties and moved them into the hardened subterranean infirmary, a feat of battlefield medicine performed under the constant threat of renewed aerial assault. The logistics of ruin were being defeated by the logistics of professional resilience. The United States Air Force was not just repairing a base, it was rebuilding a weapon system in the middle of a firestorm. As the engineers tightened the final bolts on the fiberglass mats, the radio operators in the command bunker received a flash message from the orbiting F-22 Raptors. The 4th wave was no longer a distant cloud on the radar. It was 3 minutes from the coast. The runway was ready, the casualties were sheltered, and the ammunition was in the hoppers. The base was alive, and it was ready to fight again. 4:20 in the morning, 300 miles northwest of Guam. While the ground defenses at Andersen Air Force Base were focused on the kinetic wall of the 4th wave, the offensive response of the United States Navy and Air Force was already moving toward the source of the infection. A Pate Alpha Poseidon Maritime Patrol aircraft, callsign Trident 7, was loitering at 25,000 feet. Its sophisticated sensor suite cutting through the tropical haze and the heavy electronic noise of the swarm's telemetry. The air inside the Poseidon's cabin was cool, humming with the sound of 5 high-speed server racks and the quiet, rhythmic tapping of keys as sensor operators filtered through thousands of square miles of ocean data. The mission was no longer just interception. It was a hunter-killer operation designed to decapitate the swarm's command and control. Major Sarah Jenkins, still in her F-22 Raptor high above the island, was feeding real-time signal intelligence to the Poseidon. By triangulating the unique burst transmissions used by the drones to coordinate their V formations, the American computers had isolated a specific cluster of surface contacts. These were not military hulls, but a group of 4 modified commercial heavy-lift vessels, each nearly 200 meters long, drifting in a tight formation. At coordinates 13 degrees 45 minutes north, 141 degrees 22 minutes east. These motherships were the launch platforms for the thousands of drones that had terrorized the island for the last 90 minutes. On the Pate Alpha's radar screen, the ships looked like harmless cargo carriers, but the infrared sensors told a different story. The heat signatures coming from their decks were off the charts, the result of hundreds of small pneumatic launch tubes firing in rapid succession. The smell of recycled air and stale coffee in the Poseidon's cabin was sharp, a contrast to the high-stakes digital hunt happening on the screens. The commanding officer of the 7th Fleet, operating from a hardened facility on Hawaii, authorized the immediate release of the counterpunch protocol. The objective was the total destruction of the launch platforms before a 5th wave could be deployed. The task was assigned to the USS Howard, an Arleigh Burke-class destroyer that had been running silent 60 miles to the south of the target cluster. The USS Howard turned into the wind, its deck pitching slightly in the 4-meter swells of the Philippine Sea. The smell of salt spray was heavy on the forward deck as the hatches of the Mark 41 vertical launch system cycled open with a sharp, metallic hiss. At 4:25 in the morning, 8 AGM-84 Harpoon anti-ship missiles were ripple-fired from the canisters. Each missile left the deck in a spectacular eruption of white-hot flame and thick gray smoke, the roar of the solid rocket boosters vibrating through the hull of the ship. The Harpoons dropped to a sea-skimming altitude of just 5 meters, their internal radar seekers searching for the massive steel hulls of the converted cargo ships. They were moving at 530 knots, trailing a thin line of white exhaust over the dark water. Simultaneously, Major Jenkins and Captain Thorne in their F-22 Raptors initiated a supersonic dash toward the target area, clearing their internal bays for a follow-up strike with GBU-39 small-diameter bombs. The engagement was a masterpiece of multi-domain coordination. The Pate Alpha provided the targeting data, the destroyer provided the heavy kinetic punch, and the stealth fighters provided the surgical precision to clean up any remaining launch arrays. On the decks of the modified foreign vessels, there was no time to react. They were not equipped with the advanced air defenses of a standard warship. They were platforms of mass production, not survival. The first Harpoon missile struck the lead vessel, the Pacific Horizon, just above the waterline. The 500-pound high-explosive warhead punched through the unarmored hull and detonated inside the primary drone storage hold. The result was a catastrophic chain reaction. Thousands of lithium-ion batteries and hundreds of gallons of launch propellant ignited at once. A fireball 300 meters wide erupted from the center of the ship, lighting up the ocean for miles. The second and third ships were struck moments later, their decks buckling as the secondary explosions of their own drone magazines tore them apart from the inside. By 4:40 in the morning, the 4th wave of the swarm over Guam began to stutter. Without the continuous guidance and resupply from the motherships, the drone's decentralized artificial intelligence reverted to a basic loitering pattern. They were no longer a coordinated army. They were individual targets waiting to be picked off. Major Jenkins, watching the 3 massive pillars of black smoke rising from the horizon on her infrared display, felt a grim sense of professional satisfaction. The head of the snake had been severed. The hunter-killer response had been a decisive success. The source of the swarm was neutralized, and the strategic initiative had shifted back to the United States. However, as the sun began to break over the horizon, the reality of the damage to Guam remained. The attack was over, but the work of quantifying the cost of the first swarm war was only just beginning. 6 in the morning, the first light of dawn touched the northern cliffs of Guam, revealing a landscape that resembled a graveyard of 21st century technology. The tropical sun, rising over a sea that was the color of bruised iron, cut through a thick, greasy haze that still hung over Andersen Air Force Base. The air was heavy, tasting of salt spray, burnt carbon fiber, and the suffocating, sweet stench of unrefined kerosene. Every few minutes, a gust of wind from the Philippine Sea would swirl the remaining smoke from the fuel farm, momentarily obscuring the view of the flight line where the true cost of the engagement was laid bare. By 6:30 in the morning, the damage assessment teams of the 36th Mission Support Group were moving methodically across the concrete. They worked in silence, their boots crunching on the thousands of spent 20mm brass casings and the jagged fragments of drone hulls that littered the taxiways. The systematic evaluation was a requirement of Indo-Pacific Command. A cold, mathematical accounting of a night that had changed the face of Pacific security. The final tally was exactly 30 United States aircraft destroyed or damaged beyond economic repair. The center of this tragedy was the northern ramp, where 6 F-22 Raptor stealth fighters sat as blackened, hollowed-out skeletons of titanium. These aircraft, the most advanced air superiority fighters in the world, had been neutralized not by superior dogfighting, but by small, shaped charges that had ignited their internal fuel cells while they were tethered to the ground. The sophisticated radar-absorbent coatings, worth millions of dollars per airframe, had been scorched into a blistered, useless skin. To the south, the heavy bomber aprons presented a scene of massive, structural ruin. 5 B-52 Stratofortress bombers, aircraft that had served the United States for decades, were lost. One of the bombers had suffered a total structural failure when its internal magazine of cruise missiles was triggered by a drone strike, snapping the massive fuselage in two. The tail section of the aircraft sat 100 meters away from the nose, a silent monument to the power of a synchronized swarm. The reconnaissance and surveillance fleet had also been gutted. 8 MQ-9 Reaper drones and 4 RQ-4 Global Hawk aircraft had been caught inside their specialized maintenance hangars when the roofs collapsed during the second wave. These high-altitude eyes were now piles of crushed composite and shattered optics, buried under tons of twisted steel beams. Additionally, 3 KC-135 Stratotankers and 4 C-17/NIT Globemaster transport planes had been incinerated on the secondary ramps, their loss creating a massive hole in the theater's logistics and refueling capability. The human cost, while lower than it might have been thanks to the rapid movement to bunkers, was nonetheless severe. 14 personnel were confirmed killed. In action, most of them maintenance crews and security forces who had been caught in the initial, unexpected strikes on the flight line. 48 others were being treated for a range of injuries, from severe burns and shrapnel wounds to internal trauma caused by the pressure waves of the larger detonations. The 36th Medical Group operated with a grim, professional focus, their white coats stained with the gray dust of the airfield as they worked through the final triage list. Structural damage to the base was catastrophic but localized. The primary fuel farm was a total loss, with over 2 million gallons of jet fuel consumed by the fires. 3 major hangars were reduced to their foundations, and the base's primary electrical substation had been shredded by fragmentation, leaving the facility reliant on emergency generators. The total financial loss in hardware, infrastructure, and munitions was estimated by the budget officers to be $4,800 million. At latitude 13 degrees, 35 minutes north, and longitude 144 degrees 50 minutes east, the coordinate that defined the center of American power in the Pacific, the damage was undeniable. This was the single largest loss of American aircraft on the ground in a single day since the Vietnam War. It was a stark reminder that in the era of autonomous swarm warfare, no base, no matter how remote or well-defended, was an island of safety. Yet, as the assessment teams finished their work at 7:15 in the morning, the sound of a jet engine once again tore through the humid air. Major Sarah Jenkins, callsign Claw, brought her F-22 Raptor down onto the patched concrete of runway 0-6 right. Her landing gear bumped over the fiberglass mats laid by the Red Horse engineers just hours before. As her aircraft slowed, the ground crews did not mourn the 30 lost planes. They raced toward the one that remained, ready to refuel, rearm, and send it back into the sky. The cost was high, but the base was still breathing. 8 in the morning, Andersen Air Force Base, Guam. The first heavy transport plane, a C-17 Globemaster from the 15th Wing in Hawaii, touched down on the patched concrete of runway 0-6 right. The roar of its 4 massive engines drowned out the rhythmic clatter of the remaining engineering teams still working on the secondary taxiways. As the aircraft slowed, its nose pitched slightly as the tires rolled over the fiberglass mats installed by the Red Horse engineers just 4 hours earlier. The runway held. The Red-O, air was clear now, the black smoke of the fuel farm fire reduced to a thin, gray finger against the bright tropical sky. The smell of the ocean had finally returned, cutting through the lingering chemical bite of the night's engagement. This single landing marked the beginning of the Fortress Guam transition. Within 60 minutes of the first transport's arrival, 3 more C-17 aircraft were on the ground, unloading the first elements of the transition force. These were not just replacement parts, but advanced directed energy weapon systems, and 2 additional Patriot missile batteries. The strategic surprise of the drone swarm had ended the era of Guam as a safe, sanctuary-like hub. It was now officially the most heavily defended forward operating base in the history of the United States Air Force. By 10 in the morning, the first flight of 12 F-35 Lightning II fighters from the 11th Air Force arrived from Joint Base Elmendorf-Richardson. They did not park in the neat, exposed rows that had led to the destruction of the 30 aircraft during the night. Instead, they were immediately taxied into reinforced, dispersed revetments spread across the northern and western edges of the airfield. The doctrine of agile combat employment was being implemented in real time. Personnel were already moving equipment to alternate airfields on the now nearby islands of Tinian and Saipan, ensuring that a single swarm strike could never again neutralize the entire regional capability. The strategic implications of the engagement were already being briefed to the National Security Council in Washington. The swarm attack had proven that the adversary possessed the ability to project massed, low-cost kinetic energy across 300 miles of open ocean. In response, the United States Indo-Pacific Command announced the permanent deployment of a continuous combat air patrol over the Philippine Sea. The Aegis-equipped destroyers, including the USS Higgins and the USS Howard, were ordered to maintain a 5-mile standoff from the coast. Their radar systems linked directly into the land-based Steel Umbrella network. Inside the hardened command bunker, the base commander reviewed the final readiness report. Despite the loss of $4 billion in hardware, the primary mission of the base projecting power into the second island chain was back online. The fuel farm was being bypassed by a series of temporary tactical fuel bladders flown in by the first transport, Wave. The electrical grid was being stabilized by a fleet of mobile industrial generators. The base was no longer just an airfield. It was a combat-tested fortress that had absorbed a decapitation strike and remained standing. The humidity of the afternoon began to rise, the temperature reaching 88 degrees as the sun climbed toward its zenith. The sounds of the base were now the sounds of a superpower rearming. The rhythmic thud of pile drivers, the scream of jet engines, and the constant, busy hum of heavy transport trucks created a new atmosphere of defiant industry. The airmen and sailors moving across the concrete did not look like victims of a surprise attack. They moved with the quick, precise steps of professionals who had seen the worst the enemy could throw and had come out the other side. To the north, out over the Philippine Sea at coordinates 13 degrees 40 minutes north, 144 degrees 45 minutes east, a flight of 4 F-35 fighters climbed toward the horizon. They were the new guardians of the perimeter, their sensors searching the vast blue expanse for any sign of a fifth wave. The sea was empty, save for the drifting white debris of the destroyed drone motherships, now being scattered by the Pacific currents. The engagement at Guam would be studied for decades as the turning point in the history of autonomous warfare. It was the night the United States military learned that its greatest strength lay not in the invincibility of its individual platforms, but in the resilience of its logistics and the discipline of its personnel. The 40 aircraft lost on the ground were a tragedy, but the base they left behind was now stronger, smarter, and far more dangerous than it had been at sunset the day before. The storm had passed, the umbrella had held, and the long watch over the Pacific continued under a bright, unforgiving sun.